So thank you very much, and you're absolutely right. Our ladies are definitely also able to use tools, and most probably they can do this even better than a man can do, but this is actually not the topic of my talk today, because today I want to talk about bacterial tools, and more specifically, these are tools coming from a soil-living bacteria. So some of you might say now, oh, okay, bacteria, but these are these disease-causing, ugly, small things which might make life that hard. That's true, but also in our life, there are the bad guys and there are also the good guys. So we're actually interested in the good guys, because they can do some very surprising things. For example, they are able to generate a very simple object or molecule by using a very fast and economical way to transform this simple molecule or object into another. So here shown with this stone, for example, and at the end we actually want to generate this nice figure. Bacteria are using so-called enzymes to perform such transformations, and enzymes are just tools. So what would you do? So you first would take a huge hammer, right? And smash this stone into smaller pieces, and then you would need maybe another hammer, or a tool like this, or this tool, or even maybe this, to smooth everything so that everything is fine. Well, if you have a look at these transformations, you see that this will take a while. So, what would be if we could improve such a way, such a work? And this is actually what we are doing. So we are looking for bacterial tools to improve such transformations and then to use these tools for our approaches. If you now want to improve this, what would you do exactly? You would search for new tools, other tools, novel tools to do this, and then you have to know how they work, how they function, and therefore you have to analyze them. Well, I showed a hammer before, and now you might say, okay, it's just a hammer. I mean, I take the hammer and everything is fine. Well, that's true, but what is if we have a look at such a machine, such a tool? This is even more complex, and you cannot just touch it and everything is fine. Well, in such a case, you would read the instruction or ask someone, an expert or something. But what is if there is no instruction and there is no expert to ask? Exactly. Then you would use your hands or your eyes to check the machine, push buttons, everything, and maybe finally at the end you will know how this thing works and how you can use it for your approach. Unfortunately, with these bacterial tools, it's a little bit more difficult because they are very small. They're even smaller than the thickness of a 1 cent coin compared to the highest building in the world. So they are very, very small. And so what we need is a magnifier. Unfortunately, again, we cannot use grandma's magnifier and borrow it for a week or so to study our biological tools. No, we need something more complex. And our magnifier can be divided into 3 parts, actually. So the first part is what you need to magnify something exactly is light. And light means energy. And in our case, this is delivered by a synchrotron, as we have here at Bessel. And then we need another thing. And this is a crystal. Well, some of you might be happy to see the Christmas present for her wife or for your wife, but unfortunately this is too small to put on a ring for a present. But this is another story. So coming back to the crystal, what is this? What is a crystal? Well, I'm pretty sure that some of you already built a crystal, especially if you like shoes. Or you have someone in your family or community, whatever, who really loves shoes, because shoes means shoe boxes. And what are you doing with these shoe boxes? Well, you could just throw them somewhere in the corner and let them there, but no, what you will do You will stack them. And then you have more shoes. And you will start stacking them. So it looks like a periodic arrangement of one single object. This is in 2 dimension. And then there was a sale again at Deichmann at the weekend, and you have more shoes, and even more shoes, and there we have the 3rd dimension. So finally, what you end up is a crystal, a periodic arrangement of one single molecule. The 3rd part of our magnifier is just a computer, and a lot of coffee, and maybe a dark room, but this is not necessary. So, and if you are lucky at the end, with your magnification of your biological tools or bacterial tools, then you will finally end up with a model which looks like this. Looks a little strange, right? Yeah, but oh well, that's science. And so you might now ask the question, what is it? What can we do with this? Well, this is a quite good question because with the information we have from that model, we now exactly know how this bacterial tool works, and now we can use it for our approaches, for example, and even better, we can improve it. For example, we can make it more powerful, or we can make it more robust, or even bigger, or even faster. And with these improved tools, we are able to assemble a toolbox. And with this toolbox, we might be able to produce something which we can use at the end. For example, and this is actually our goal at the end, we try to use these tools to transform a very simple molecule into another molecule which might be useful for the production of renewable biofuel. Sounds great, but there are 2 additional problems. And one problem is that the tools we are working with, or the bacteria where these tools are coming from, they are very lazy. They don't want to work. So what we need is something like a workhorse, which might be able to use our tools. So we have our toolbox and use the workhorse. But now there's the last problem, and for this I need someone from the audience here. It would be cool if there would be someone. No? Come on. So we have our toolbox. Great, awesome. So we have our improved toolbox, and we have our workhorse coming onto the stage. So thank you very much. So and the problem is, yeah, go ahead. Yeah, see, and exactly that is the problem. He has absolutely no idea what to do with this. And this is the last thing we have to manage. We have to teach the workers how to use these tools in order to produce the molecule we want to. Yeah, thank you very much. Yeah, that's it.